Okay, so this is the second video for integration by parts. The formula's up there in the top right hand corner, and first example is we're going to integrate something a little bit more challenging, which is x squared multiplied by e to the x. Okay, so u is going to be x squared, dv by dx is going to be e to the x. So we work out du by dx and v next. So obviously we know e to the x integrates and differentiates to e to the x, so that one's easy, and du by dx is going to be 2x. Alright, then I'm going to use the formula to substitute all that in, so therefore I is going to be uv, which is x squared multiplied by e to the x, so x squared e to the power x, subtract the integral of v, which is e to the x, multiplied by du by dx, which is 2x with respect to x. So you can see like there's a problem there because our second integral is a product as well. Okay, so these questions are slightly more challenging than the previous ones we've looked at, because to be able to integrate x times e to the x, because it's a product, I'm going to have to actually use integration by parts on that as well. It's like the calculus version of the film Inception. Integration by parts within integration by parts. So if we integrate x times e to the x, so I'm just going to try and do this in one go. So u is x, dv by dx is e to the x. So uv is going to end up being x multiplied by the integral of e to the x, so that'll be xex. Subtract, so v is going to be e to the x. And then if u was x, alright, then du by dx is going to just be 1. So just in one line there. But obviously, when you were doing these questions, I'd recommend you not to do that. Is to break it up and set out the working like we've been doing. So that's going to give us x e to the x, subtract e to the x. Done. Okay? Just shrink that and put it over to the left for the rest of our working out. So now going back to our original integral, therefore I is going to become x squared e to the x, subtract 2 lots of x e to the x, subtract e to the x, plus an arbitrary constant, which I haven't put in there. So if you expand all that, we're going to get x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Well, I didn't figure it at that time. Okay, that's it, done. That's about as tough as they become. Okay, when you have an integration by parts within integration by parts to get to your answer. So just be careful of that. If that second integral, when you substitute everything into the formula, is a product, just be wary, you are going to have to do integration by parts on that as well. It's not straightforward. Right, so for this last example, I know we've already integrated log x, but what this example is for is how to use integration by parts to work out definite integration. So if we're integrating it between a limit. Okay, so like I said, if you've got a log in your question on the problem, you want to let u equal log x. So dv by dx is going to be equal to 1 in this case. Dv by dx, du by dx is going to be equal to 1 over x. And if we integrate 1, we get v, which is just x. Alright, so you stick all that into the formula. Okay, so I is going to become uv, first of all, which is going to be x log x. Now that part has been integrated now, so we're just going to put square brackets around that bit because this bit is now being integrated. Okay, so it'll be a 2 and a 1 there. Subtract the integral of v times du by dx, so x times 1 over x. With respect to x, and that is going to still be integrated between 1 and 2. Okay, it's just we haven't integrated that part of it yet. the x and the x, but as we know, cancels. So that is I x log x between the limits of 2 and 1. And we do all the limit bit right at the end. So we get down to a point where everything is ready to be subtracted. So that's the integral between 1 and 2 of 1 dx. So then I is going to become x log x between 2 and 1, subtract, and the integral of 1 obviously is x between 2 and 1. Okay. Plus C this time, do we need it? No, we don't, because it's definite integration. So this is what you'd be using to work out areas into curves and things. You're going to use the arbitrary constant if it's not between two limits. So I is going to be 2 log 2, take away log 1, take away 2, subtract 1. Use your calculator if you want to, but I want to leave this in terms of log. Alright, so 2 log 2, we leave that in terms of log, but you should remember log 1 is 0. We work in C3, we did log graphs. So you'll have 2 log 2 minus 0, and then 2 take away 1 is 1. So that's it, done. That's our answer. The integral is 2 log 2 subtract 1. Alright, so you leave it like that. If the question's asked you to leave your answer in terms of log 2, you could leave it like that if your answer, the question's asked you to find an exact solution. Alright, you know, if the question's asked you to give your answer correct to 3 different figures, then you'd use your calculator and you could work that out and round your answer. But if in doubt, just leave it in exact form. Okay, well that's it for integration by parts and integration by substitution. So off you go with those exercises, and good luck.